we just announced Sundae V4. So let me switch my... So a little while ago, a couple days ago, we announced Sundae V4, which is the next version of Sundae that we've been building. We've been sitting on this for a while, keeping it quiet because we wanted to build it and have it ready, and almost ready to release by the time that we announced it. Because I'm getting really sick of these hype cycles where people say, we're super excited to bring blah, 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 and then it's 8 months or a year out. So we're going to be doing the first rolling release for Sundae V4, meaning we release the first initial features in August. We'll be launching a testnet, so here's an exclusive, sometime next week. So stay tuned for that. We'll be able to, you'll be able to play with some of the features that are coming in Sundae V4 on the preview and maybe pre-prod testnets. So we spent a lot of time over the last couple of years thinking about what does the next iteration of Sundae need to do. When we built Sundae V3, it started as Aiken is out. Let's just see how much faster we can make Sundae V1 and not change much about it. And so it was really started as an experiment to say, okay, what are the minimal number of changes we need to make a much better protocol? And that got us from Sundae V1 could process 2 to 4 orders per batch, and Sundae V3 could process 35 to 38 orders per batch at high throughput. So it was a step change difference, but we didn't really re-examine what the core protocol should be. We fit a lot of features within that same framework, but overall, the kind of basic structure, there's a pool, you have a list of orders, we're going to loop through each of those orders and execute them in a certain order. That core structure stayed the same. And so with Sundae V4, we got the chance to really rethink from the ground up what that difference, or how we would design things differently if we could. And this is the result. And if you're wondering, by the way, Sundae V1, Sundae V3, where did Sundae V2 go? That was the complete UI rewrite we did. We, spent a while rebuilding our UI after our launch, and then we called that Sundae V2. And then when we built Sundae V3, we didn't want people to get confused. Like if we called that V2 of the smart contracts, people would have said, oh, I thought you just released V2. So, but now people get confused because we skipped V2 in their minds. So it's a little silly, but as a joke, I almost considered calling this Sundae V5 just to mess with people, but Sundae V4 it is. And so we're going to do a series of these live streams to talk about different features and different kind of design philosophies behind Sundae V4. But the first one that I want to kick off with, which is the one that I think really matters to your average everyday trader, is this either automated or atomic routing. And this is the notion that Sundae V4, internal to itself, can act like a DEX aggregator. So what does that mean? I've got a little whiteboard here that we can sketch on to explain. By the way, just like all past live streams, this works much better if people are asking questions. I see we've got a couple viewers, 4 viewers right now. So, if you're around, feel free to ask questions. If you are watching the recording later, feel free to tweet questions at either the Sundae account or myself on Twitter, Quantemplation. I'm largely off Twitter, but I will answer. I can't resist answering questions if you ask them. So, but okay. So the core idea behind automated routing or atomic routing in Sundae V3, we had this notion of a destination. You could place an order. Let's say this was, I want to swap ADA for night. And when you built that transaction, you could place a destination. So when this executes, this takes in your funds and then has on the outputs the night. And this gets paid to a destination, which is our term for an address plus a datum. What that inclusion of the datum means is that if you want to compose this, you could pay it right back to the order contract with a datum describing the next step of some complex route. So you could say, okay, I swapped ADA to night. Now I want to swap that night to USDM. And in principle, though nobody ever really made use of this, that destination could be some other protocol. So this could be some smart contract that said, okay, now that I have USDM, lock as collateral on Liquid. So you could build these chains, and this was the easiest way, kind of the lowest risk way to build composability on Cardano. There's two main problems with this, though. First, your order output could only go to one address and datum. So it was not possible to say, hey, I want to swap ADA to night, and then have half of that night swap to USDM, and half of that night swap to USDC. So now I'm going to put this in red, because this was not supported by Sundae V3. And then maybe you wanted to take the result of both of these. And I'll do another red arrow. And deposit as liquidity. You could imagine this flow, but because of this branching and merging, it wasn't possible to do in Sundae V3. The second problem is a little bit more subtle. And this one could have been solved with, you have an intermediate routing contract with its own particular logic that would have been a little annoying to write, but if you had a common recurring use case, you could write something like this. The more subtle issue is that this introduces something called inventory risk, which means I have to commit to this swap when I build this transaction. So let's say right now, I estimate that I'm going to get, I don't know what the price of ADA is. Let's check. Or what the price of night is. Let's go check. ADA for night. So I can estimate that I'm going to get 1050 night. And with slippage tolerance, that's going to be at least 1019 night. So let's say 100 ADA for at least 1019 night. Now when it executes, I might actually get slightly more. I might get 1025 night. Or, and I'll put these back in white, I might get slightly less. So let's say 1011 night. Because there may be a small backlog of orders in front of yours, or it might take a few seconds for your order to make it into a block and somebody else's order executed before yours. So, this estimate isn't exact, and you could face slight slippage in between when you estimated your order and when it placed. And that has compounding effects, because when I construct the datum for this order, I also have to estimate, okay, I could get maybe 1025, maybe more, maybe less, maybe 1019, who knows? And I have to set a minimum. So if I'm swapping night for USDM, and let's say I have 1019, I might get 19 USDM. So this might be at least 19 USDM. But let's say that both of these markets shifted slightly in between when you built your transaction, and you're pressing the buttons on your hardware wallet to try to confirm it. That takes some time, and so these markets can drift in that time. And so maybe all of the best that this market can do to satisfy your order with 10-11 night is 18 USDM. And so it sits there and it doesn't execute. And that means that even though I was trying to swap in total ADA for USDM, even though that was kind of my total end goal, I got stuck with this intermediate asset night. And sometimes that's okay for people, but more often they want USDM. They want it to, if it can't execute, don't execute at all. So this was a big risk, and we saw people not using this routing because they were worried about this inventory risk, this kind of getting stranded in the middle. So with Sundae V4, orders can be arbitrarily complex up to what the transaction allows. So what that means is I might say, I want, all right, here's 100 ADA. I want at least 15 night and at least, or what did we say? At least 10, 19 night and at least, let's cut that down a bit. So like 800 night and then, 2 USDM. I don't know if that's how the numbers exactly work out, but I place that as the constraint on my order. And now to execute that order, we can bring in the ADA night pool. We can bring in the night USDM pool. And we can bring in the ADA USDM pool. And we can split this 100 ADA, maybe 70% of it swaps to night, and then that night swaps to USDM, and 30% of it swaps ADA to USDM. So on the outbound side, you get, whatever that is, maybe 20 USDM. And it's slightly more efficient than any one of these routes. It's probably significantly more efficient than just through ADA USDM. And it produces this, well, actually, I wanted night and USDM. So let's say I get 5 USDM and 850 night. And internally, what that looks like, if I bring this inside, oh. So we have, oh, it's not going to cooperate. Yeah, I saw the Gaston, who's managing the Sundae Labs account for me, said, leave your questions. This works best if you make it a question-y stream, if it's interactive, so please do, if anybody has questions. We've got around 11 concurrent viewers right now, which is great. So what this might do internally to the transaction is it says, okay, here's 70 ADA for against the ADA night pool. And I'm going to get out, let's say 90 night, or no, 900 night. I'm going to split off a portion of that and bring along some of the remaining ADA and this pool, the Night USDM pool. I'm going to do this one down here. Let's say I used 20 ADA. No, this would be, I'm going to use 50 Night and swap that for, I'm going to do this in a little less fidelity. You get the idea. It's hard to make these diagrams on the fly. So that maybe this is like 2 USDM. And then the remaining ADA from up here. Oh, no. And this over here gives me the remaining 3 USDM. So all that is to say, the net effect of these kind of 3 interior orders ends up being this total order that you get out. And the best part about this is that this gets considered, one, this gets executed in a single transaction. And 2, this is decided at execution time rather than when you build the transaction. So you still set these limits so that you ensure you're getting some minimum amount. And if you can't at least get this, then you don't want it at all. And the order contract checks to make sure that the scooper isn't kind of trading against you and skimming off and just giving you your minimum, right? Because this might typically be a problem with a naive implementation of this, where, hey, you just said you wanted 800 Night and 2 USDM, so we're going to give you 800 Night and 2 USDM, and the scooper might keep 50 Night and 3 USDM because you didn't, you only said you wanted this. So the smart contract actually looks to make sure, okay, of the steps that got executed, did I get all of the surplus? And so we had a screenshot of what this can look like in fairly complex cases. So this is me swapping an imaginary token Mango to Mint. And at this particular time, it guessed that the most efficient way to do so is to split that swap among Strawberry, Mint, and ADA, and then swap the Strawberry and the ADA to Mint and get an amount on the on the end here. And in this case, going with this route got me 6.2 thousand Mint more than if I had just swapped directly against the Mango Mint pool directly. So internal to the Sundae protocol, there's still a place for DEX aggregators because they'll split your order across different DEXs. But even within SundaeSwap, we will evaluate, well, not we, the protocol will evaluate what the optimal routing of your funds are and give you the best order. Somebody in the chat, somebody from the Sundae team says, perhaps a naive question, but how does this affect fees when splitting and routing like this? And that's a great question. Obviously, including more pool UTXOs and invoking more smart contracts will increase the ADA transaction fee. And the solving to find you the most efficient route takes more effort and CPU on behalf of the scoopers. And this removes some opportunities for arbitrage, which lowers the volume on the pool, meaning it lowers marginally, not a huge amount, but marginally the fees earned by liquidity providers. So to make up for that, the protocol has this this notion of a budget. And so when you place your order, it'll be a setting up here in the settings, and it will be a property of the route you pick, but you specify what your kind of budget for that transaction fee is. The higher you set it, the more aggressive the protocol will be in splitting your order to get you the best fee, but it will never exceed that budget. So if you always just want to swap through the most efficient or the most direct route and pay the fewest fees, even if you're going to get less out the other end, you can set your fee budget. And we haven't set the fees. These are all dummy numbers, so don't take screenshots too literally. It's all just preview. But you can set your budget to, I just want to execute directly. You can pick that route. But if you want to leave it open and you want to say, hey, go ahead, Scooper, be aggressive, as long as it gets me more of the output token than the fees that I'm paying. So in this case, I think we've modeled Mint to be worth about $1 in kind of the way that we set up the pools. For paying 6 extra ADA, I'm getting $6,000 worth more on my trade. So that's a fairly clearly a much better outcome. And remember, this is all happening atomically within a single transaction, so it won't stall, and you won't get left with 3 intermediate tokens like this, which I think is a really, really important property. What's really cool is that these limits or these transactions don't have to be constrained just to the Sundae protocol. And I have to say this carefully because many protocols aren't designed in a way that can be composed, but up to as much as the protocol can allow, and as much as we've implemented support for indexing opportunities and executing them, the protocol can include other operations here to improve the efficiency of your order. So here's a simple example. Fallen Icarus on Twitter has talked a lot about the DeFi kernel. And the idea behind the DeFi kernel is that people or large institutions can place kind of long-standing orders that operate very similar to this for specific prices, and they can update those prices efficiently. We can, and plan on implementing, index these DeFi kernel orders, and if there's an order here, and the most efficient route would be to swap your ADA for Sundae via the DeFi kernel order book. Maybe it's somebody, is an off-limit price and that it's particularly advantageous right now. Then we can execute that DeFi kernel order. So I'll label this DeFi kernel. We can bring that in to swap your ADA for Sundae, and then swap that Sundae against all these pools, and maybe that gets you more on the output. Another example that I'm really excited about, Butane is planning on launching a product called ADA-B, which is a synthetic ADA token. The reasons they're planning on creating a synthetic for ADA are quite subtle. You'll have to ask them. But you can, it allows you to borrow and swap a synthetic ADA in pairs that track ADA. So maybe you can lock, 100 USDM and borrow some amount of synthetic ADA. But the interesting property here is if I lock ADA itself, I get A-to-B 1-to-1. There is no, if I'm locking USDM, I have to have some health ratio. I lock $100 worth of USDM. Maybe I can only mint $70 worth of A-to-B to make sure that there's room to liquidate it if the market starts crashing. But if the collateral you lock is exactly tracking this price, then you can do so you can lock it up exactly 1-to-1 with no fee. And so what the order will consider is, let's say This is on the butane protocol. Let's say I am trying to swap in total 10,000 ADA for gold. So for 10K, I don't know what it would be worth right now, but let's just say 1,000 Midas, which is the butane synthetic. Now maybe the pools between ADA and Midas are very shallow. So maybe naively what you could do is say, okay, I want to swap the ADA for BTN and then the BTN for Midas. Maybe that's like a slightly more efficient route. But you're going to pay you're going to pay the liquidity provider fee and the slippage to swap your ADA to BTN, and then again on the BTN to the Midas leg. So what the Sundae protocol can notice is, hey, why don't we take that 10K ADA, lock it in the butane protocol to mint the A to B, and maybe the A to B and Midas pair is very deep, and we swap through that, and that gets you a more efficient route. So we've actually prototyped this and implemented this with the butane protocol, and we can integrate more edges like that. So when there's liquidations that can be done on Liquid or other lending protocols, when there's borrowing and hedge positions, that's a bit more subtle because of the loan to value ratio and things like that. But the point is, anywhere that you have a protocol that allows you to exchange one token for another can be integrated into this solver graph, so long as it can be spent in the same transaction as when we execute this order. That's why I say that carefully, because I would not expect to see, for example, us routing through MinSwap, not because we don't want to route through them if it's better for the consumer, but because the current MinSwap contracts don't allow direct routing through the pools, so far as I know. If there's anybody on the MinSwap team who believes otherwise, feel free to reach out. We'd love to work together. But yeah, so the Sundae protocol will look for these efficient routes to swap through, and that's important because it means that overall more volume will come to the Sundae protocol because it will be providing better prices. That means that there's a better return for liquidity providers, and that means that we'll see TVL growth on Sundae, is the hope. So I'll pause there. Anybody in the chat have any questions about this so far? I'll kind of take a breather. And once I've answered all your questions, or if there are none, I'll talk about, like, why did we not do this for Sundae V1 or V3? And what changed about Sundae V4 that made this possible? I think that was what I'll talk about next, but if anybody has any questions, I'll answer those first. We have about 9 viewers. We peaked at about 19. Seems like about half of you are joining from your iPhone, so hi to all those on mobile. All right. I don't see any questions in the chat. I'll answer them if they come up, but I'll assume that there are none for now. Like I said, if you're watching the recording afterwards, or this got sliced up into a Twitter clip, feel free to send us questions. If I see them, I would love to answer them. I'll also be talking about this and other topics in future streams, so no worries. Let's talk a bit about why this is difficult. Why other protocols have not, in general. Some have, we're not claiming to have invented this idea, but it's been really particularly hard to integrate into DEXs. Matt asks, would a strategy use this routing as well? And yeah, that's a great question. So for those who don't know, strategies are a Sundae V3 feature. where you could lock, 10K ADA and then say, I'm not actually ready to do a swap, but I'll tell you when I am. And then you can sign a little payload and send it directly to the scoopers, and that enables them to execute. And that's for more like reactive and on-demand trading. So on our UI, we've used that for dollar cost average and trailing stop loss. These features weren't heavily used, so we kind of put implementing more on hold. But we've brought the idea right back to Sundae V4, so there will be strategies as well. And yes, they can take advantage of this routing. One thing I should mention, by the way, before I move on, this routing is optional. So if, for whatever reason, you only want to route through a specific pool or a specific set of pools, that option will be available. Maybe not directly at launch, but eventually. And the reason you might want to do that is, say, you are trading on behalf of a regulated entity, and you don't want to have to explain why there is a random swap through, shitfart coin on your list of historical transactions. Even if it, got you more money, you want to stick to, I'm just trading ADA, Night, and USDM. So you can constrain the space of the solver to specific pairs, specific routes, things like that. If you think you can do better than the scooper routing strategy, you can insert your own. So these are like more advanced use cases. But the default, if you just swap through our UI, it'll do this for you. And strategies will be able to take advantage of that as well. Okay, so let's talk about why this has historically been difficult. And the reason is two intertangled reasons. One, a fairness argument. Fairness. And two, a security argument. So the reason batchers exist and are a feature in my mind on Cardano, I know many disagree, but there's a lot of talk about how to build a batcherless scooper. And even if you can solve the contention problem, I think that batching protocols and scooper, like the scooper protocol that we have, provide an advantage, which is this serves the role of what's called the NBBO. If you are trading stocks like on Robinhood or the New York Stock Exchange, the exchange that you work with is legally bound to honor the national best bid or offer, which is essentially saying, hey, if you place an order, they have to give you the best price there is. They can't quote you a price of $10 when somebody else is selling it for $5 and pocket the change themselves. And in protocols like order book protocols or open batching protocols, this can happen because there can be this can be violated because an automated bot out there can basically front run your order. And maybe you got your order on chain first, but because they're an automated bot, they can batch the order and include their order before yours. And there's not really a good way to enforce that totality of fair ordering right now without some notion of a batcher. There's some really interesting and esoteric ideas that Sundae Labs plans to explore down the line. And when we feel like we can remove batching while still preserving this property, which we think is an important property for our users, then we'll implement those. But for now, this is being able to kind of do one, permissionless batching, or two, these kind of composed batches is really hard to make sure that whoever's composing that batch does so in a fair way. And two, it's really, really subtle to get this behavior right if you approach it naively because of something called double satisfaction. So let's say we bring in 2 orders and 2 pools, and each pool contract checks its own input and output. It says, okay, I had X, Y going in, X prime, Y prime going out, A and B, A prime and B prime. And then each order, maybe there's 2 orders from the same user, or other kind of subtle corner cases. If you don't write the smart contracts correctly, the order contract could be double satisfied by one output. So here, let's say this is somebody swapping, ADA for night. I placed a limit order and it's ready to execute. And I'm also swapping USDM for night. And each of these says, oh, at least 10 night, please. And by swapping these, maybe I can get 1,000 night because of the current state of the market. So I'm going to have an output with 10 night to the user's address. If this order contract is just looking, hey, did the user receive at least 10 night? Both of these are going to be satisfied. Both of these are going to see an output with 10 night and say, oh yeah, cool, perfectly satisfied. Meanwhile, whoever executed this batch, either permissionlessly or not, is going to be able to go and take 900 night. And this is kind of the most naive example. There's all kinds of really subtle permutations of this. And especially on this fairness front, knowing if you have 10 pools involved, how do you know what order, which of these orders got executed against which pools, just by looking at the inbound and outbound X and Y, or A and B. The smart contract on chain, if it wants to prevent the scooper, even if you solve this double satisfaction problem, and it wants to prevent the skimming of any surplus funds, that gets really subtle because you don't have the information of how the scooper used those funds from those orders to get from XY to X prime Y prime, or from AB to AB prime. And so when we were building Sundae V1, we backed off this very hard because it seemed like a really hard problem to solve. And we were already super resource constrained. We just wanted to get out the door. And when we looked at Sundae V3, again, we were in the mindset of let's change as little as possible. And so what the pool contracts do is they iterate over each order and they just evaluate, okay, this one needs to be executed, this one needs to be executed, and they can keep a running sum, a running state of the pool. So after executing one order, they can say, okay, this is X1, Y1, and let me erase. This one might be XN, YN. If we're iterating over each order, we can keep this running tally to say, okay, X1, Y1, X2, Y2, X3, Y3, and we can check, one, that the pool logic is honored in each of these intermediate steps up to the final one, and 2, that for this intermediate step, because we know it was for this order, we can know what the surplus was and make sure that that gets routed to the user instead of skimmed. And it's also way more efficient to loop over this list of orders once in the pool contract rather than having to do it every time in every order contract. And so that's, how we got to being able to execute 35 orders in Sundae V3. And so when looking at this and when realizing it's this step-by-step inspection of the intermediate states that gives us the safety in composing transactions, we landed on this new idea called the transcript. And so whenever you spend a pool UTXO to execute a batch transaction, the redeemer includes the transcript of all of the actions that you're performing on that pool. And the pool contract only cares about that transcript. And it says, okay, yeah, somebody did a swap and then a deposit and then a deposit and then a withdrawal and then a swap and then a swap. And then we'll talk about this in a future session, but we can add new operations to that are interesting and powerful. But when it's checking each of the intermediate invariants, the pool contract can just look and say, hey, is my core property, the thing that matters to me, satisfied on each of these intermediate steps? And likewise, the order contract can go and look at the transcript. Each of these is labeled with what order it is for. There may be multiple transcript steps for the same order. So this is how we implement like zaps, for example. And there's a lot of really powerful things we can do with this. But the order contract can go and look at just the transcript steps that are relevant to it and make sure that it keeps a running total of what its entitled surplus is to prevent skimming. And it can do that across all the pools. So now each pool contract is just checking its transcript, and each order contract is going and looking at these transcripts to make sure that it was treated fairly, that there's nobody coming in and skimming something off the top. And so this transcript as a language of interchange between all the different components of the contract was a big unlock for us, design-wise. And it was a big way that we are able to coordinate different parts of the contract. And this will make more sense in future sessions when I talk about our modularity and our composition. But like this was kind of the birth of Sundae V4. When I realized this is how I would design something that enabled that composability, because now if I have another pool included here, it has its own contract. Swap, swap, swap. And a given order might be threading, okay, I'm going to swap here. This is my first step. Then this is my second step. And then this is my third step. Or maybe the deposit is my third step if I'm doing like some kind of deposit. And I can check the fairness of each of these steps from the order contract. And each pool can check that, hey, assuming that we have the funds available, each step is honoring the logic of the pool. You know, to make this concrete, this would be the like XY equals some constant for the constant product formula. It can check its liquidity invariant on each step. It kind of just all meshes together. And this is what makes Sundae V4 and all its like powerful composition possible. And so when we look at something like this transaction on chain is going to have, assuming it's the only order that's executed, each of these pools is going to have their own transcript entry describing how it gets swapped. And the ledger is going to enforce that the transaction is balanced. The pool contract can say, oh, okay, the final balance at the end of my transcript, here's what the reserves are that stay in the pool. It can check, it can compare that to the inputs and outputs. So this, it's just hard to overstate how big of a a key idea of Sundae V4 this transcript represents. And it unlocks a lot of really cool features in the other things that we're going to talk about in future streams. Cool. So that was a lot of yapping on my part. I've gotten a couple good questions from Matt. Anybody else in the chat? We're up to, we were 15 viewers and now we're 12 viewers. Any other comments that people have? Anything that you want to ask? Do you want to know if something is possible? So while I wait for some questions, these features probably won't be available right when we launch, but just to give you an idea, if I place an order that says, here is 10K ADA and 15K USDM, and I want at least X of these LP tokens, Y of these other LP tokens, and Z of these other LP tokens. When we auto balance this order, when we auto route this order, what that's going to look like is potentially some swaps to get the 3 different tokens in these pools, and then deposits to produce these 3 tokens. So with Sundae V4, you'll be able to deposit across 10 different pools at once, provided the execution limits allow it. Similarly, what you might do, we might build a feature where I say, here is LP tokens for the ADA USDM pool. I want to swap them for LP tokens for the ADA USDCX pool. So what is the solver going to do to satisfy this order? Well, first, if there happens to be a pool with these 2 LP tokens, and it's deep enough to give you a good trade, it'll do that. But probably the more efficient way to do this is going to be, we include the first pool, the transcript is going to be a withdrawal. We include the second pool, the transcript is going to be maybe a swap. So like, maybe this would look like, okay, I'm going to withdraw the ADA USDM. I'm going to swap the USDM for ADA. Now I'm going to include the ADA USDCX pool. Maybe I'm going to swap some of that ADA for USDCX, and then I'm going to do a deposit. So this is how the transcript would look. Obviously, each of these has the details about how much you're withdrawing or swapping or depositing. But the effect is that you can rebalance across pools in a single transaction. And if you combine this with one of our other features, which is concentrated liquidity, where you have different ranges that people might be providing liquidity across, it means you can rebalance from one price range to another in one transaction. So this is a really powerful primitive. Let's say there is liquidations, and you have an LP position. You can withdraw to get access to the collateral, liquidate the, whatever thing needs to be liquidated on Liquid or Fluid or some other lending protocol, swap the collateral you got back to your original tokens, and then deposit them back to LP tokens. So we can build these flows either as strategies or as just orders in conjunction with other protocols that really just allow you to compose these. And again, it's because we can decompose all of these operations down into this simple transcript. So this is one of the features that I'm most excited about with Sundae V4. And also part of why it has taken quite a while to build, because you can imagine getting all the details here correct, and asking an auditor to review all of those is quite subtle and quite difficult. But yeah, cool. I haven't seen any questions come in. I'll give it, 4 more minutes for questions to come in. Streams like this are best when they're interactive. I keep saying that, so please don't feel shy. Oh, awesome. So Prometheus Pool asks, how expensive is the solving for automated routing? If multiple users are doing the same route at the same time, can that solving be reused? How do overlapping solver paths in the same scoop interact with each other? So this scales with the number of different pools that could be involved in these routes. And the, let's go back to this screenshot. The budget you set for how aggressive you want to solve also bounds the computation. So if somebody is only willing to pay 1.5 ADA, then, we're going to stop after evaluating 1 or 2 possible splits. If they want to pay 10 ADA, we're going to go all out. And the algorithm for it is quite sophisticated. Maybe I'll do a stream someday about how that works. It's a water filling algorithm. So we look at all of the edges in the graph between your what you're giving up and what you want to receive. And we look at what the marginal improvement on that edge is. And then we allocate tokens to the best edge until it is equal to another. And then we start allocating tokens to multiple edges until, they level out. So it's kind of a water filling algorithm. But there's lots of clever optimizations you can do there and parallelizations that you can do there. So in practice, it's really cheap. Maybe in the I didn't prepare, so I don't have the UI running locally on this computer. Otherwise, I would go in and type in some value and show you how quickly the API responds. But we can answer queries to build these routes for the front end in under 500 milliseconds, and that's with normal Lambda routing delay and things like that. So it feels very instant when you're entering it in the UI. And when the scooper is doing it kind of at scale, it's also very efficient. As for whether some of that work can be reused, building the graph can be pre-computed. So like the data structure that allows us to query that has been designed so that all of that work and the kind of marginal benefit of each edge can be reused and efficiently updated as we process orders. But and so that makes each individual solve pretty fast. And because that solve is going to change those pool states, it's not the actual work internal to the solve. It's not very reusable. But, like I said, building the data structure that allows you to do those queries is the reusable part of the work. And what that also allows us to do, by the way, so the Sundae V1 and Sundae V3 scooper does kind of a round robin individual pool solving. So of all the pools with outstanding orders, it picks the one with the oldest order outstanding, and then tries to build a batch for that pool and submit it, and then it moves on to the next pool. And that means that when we went from 2 to 4 orders to 35 orders, that was a big step up, but maybe optimizing too much for the wrong thing, because an individual pool very often never gets that loaded. I think the biggest swap we've seen was during either some big meme coin launches or during the night launch. We saw 15 orders, 20 orders in a batch, never the 37 or 38 that is the theoretical maximum, because it's just too easy to build the batch and burn down the queue that fast. And so what you would see is under load, we'd be processing these large batches for one pool, but you could only fit so many pools per block. And so if there was lots of activity across many different pools, the execution time could still feel slow because, if you had 20 pools all getting orders in real time, each one of them is only a batch of one, and you can only fit so many of those in a block, maybe like 5 or 6 of those per block. With this, we do a global ordering solve. So we look at literally the oldest executable order, we fit it into the batch. Then we look at the next oldest order and we fit it into the batch. And then we look at the next oldest order and we fit it into a batch. And we just keep doing that until the batch hits its maximum size, and then we submit that to the chain and we start a new batch. And what that does is we're far more efficiently packing orders into batches so that we're not flooding the chain with these like heavyweight, expensive transactions. Because if you have a transaction that uses, for a single order, there's some overhead costs just from, booting up the VM and all that. If you're using that to process just one order, there's a lot of wasted block mem units in there, for example. So even if, and we're still benchmarking, we're still optimizing, even if the maximum batch size, how many orders against one pool comes down slightly from V3, the overall throughput improves because we can more efficiently pack things into blocks, and the overall execution quality improves because we're doing this splitting and routing across orders. So hopefully, thank you so much for asking that question, Prometheus. Hopefully that answers it sufficiently. Feel free to tweet at me if you kind of wanted a follow-up or anything like that. Anybody else with questions? Otherwise, thanks to I'll wait until 4:15 after. Yeah, great follow-up. So Prometheus asked, if you set a really high fee for solving, will the solver stop at some point when it thinks it can't do any better and refund you some of the fee? Or do you need a rough kind of guess, like 0.1% of the order? We're still figuring out what exactly the fee policy would be. And this can be changed over time. Right now, the simplest thing is for you to just set your upper bound, and the pool, the scooper will say, okay, there is a per pool fee when, like, how many pools we bring in to satisfy your order. If you're split across 3 total pools, then it costs this much base. If you're split across, 1 pool, it's a little bit cheaper. If you're split across 10 pools, it's more expensive. And then a per hop. So if, for example, splitting across 3 pools might be more expensive than splitting across 3 pools that have some additional or internal logic like hops between them, because that incurs more transaction fees. So we're still narrowing out on exactly how that budget will work. Our intention is for that to go, like any surplus, to go back to you. But also we won't, the solver takes into account where it can. Some corner cases, it doesn't know the value of a token. But if, for example, any of the pairs goes through ADA, first off, the front end will only give you potential solve routes that are marginally better, like that get you more of your resulting token than the ADA fee you're paying. And we'll do that estimation based on what we think the value of each token is. Doing that inside the scooper, it will do that logic, but it can only do that for the for the pools it knows about in that transaction, just because of, in order to keep it efficient. Anyway, all that is to say, the scooper will the software does the the smartest thing that's available to it without blowing up complexity. And yeah, so I don't have a more satisfying or crisp answer for that right now. But it's 4:15. I've been going for about an hour. So thanks to the, I think we capped out at 19. Thanks for the 19 viewers who tuned in, all the people watching the recording or the snippets later. Hope you enjoyed the stream. Feel free to ask more questions on Twitter or show up to another stream. I will probably, in the next stream, talk about concentrated liquidity and custom vaults. And then we'll probably do another stream about linear swaps, which is a semi-new invention that we're bringing. At least it's new-ish to Cardano. It's got some... We took an existing idea and we think improved on it in a fairly novel way. So we're really excited about that. So thanks for coming to the stream, everyone.